This video we are going to do insertion sort. As in our last video we did selection sort, so it's time for insertion sort. Now firstly, as some bullet points about insertion sort. So firstly, it is an in-place sorting algorithm. In-place sorting algorithm means that while sorting this array, it doesn't create any another array in the memory, so it is fairly space efficient sorting algorithm. Secondly, efficient for smaller data. So it is fairly efficient for smaller data, but as the data in the array increases, the efficiency decreases. It's a stable sorting algorithm. So now insertion sort is a stable sorting algorithm, and basically there are two types of sorting algorithm. Firstly, a stable sorting algorithm, and secondly a unstable sorting algorithm. Now just remember that this is a stable sorting algorithm, and this point doesn't relate to the stability of the algorithm. It's something different. I'll tell you this in some other video. Now just memorize that this is a stable sorting algorithm. The complexity of is O and K. Now as you remember that the complexity of the selection sort is O n square, so it is fairly efficient as compared to selection sort. Now it comes to algorithm. Now as you can see, the algorithm is looking pretty complex. The basic point of the algorithm is that we divide an array in two parts. First part is sorted and the other part is unsorted. Now here example, we divide this array in two parts. This part 2 is sorted because it doesn't have any other number to compare, so 2 is sorted, and while this is unsorted. And as we increases I and j, whenever j is greater than I, we just put the value of j at I. Now I know you didn't understand it quite well. Now let me take an example. Now at first it looks like bit complex, but first see this. J must be the value of j must be always equals to or greater than 0, and the array at j and the value at j, if the value at j is greater than I, then only we enters in the loop. See, firstly we put the value of I at an element. Secondly, the value of j is 1 less than the value of I. So we enter this loop only when the value of j is greater than the value of I, and then we do something. But what we do, I'll tell you. And then when we comes out of the array, we enter this element in one greater position of j. Now see, consider this array 2, 8, 7, 1, 5, 10. 2 is greater than 8. 8 is greater than 2, so it is okay. As I told you that the value at j, if it is equal to the element, then we'll go into the array. Now 2 is less than 8, so we'll increment, as you see, we'll increment I and we'll also increment j. Now I becomes 2. Now I is pointing to 2 and j is pointing to 1 less than I, which is 8. Now as we see that 8 is greater than 7. Now we'll have to do something. Now what this tells is that put the value of 8 at 1 greater than the value of j. Put this value here and then decrement j. We put this value here and then decrement j. As we decremented j is pointing to this. Now j is smaller than I. Now j is smaller than I, we comes out of the array. As we comes out of the array, now we'll put j plus 1. J plus 1 is what? J plus 1 is this box. Now we'll put the value of the element. As you see, we store the value of I in a variable called element. Now we'll put the value of element here. We put the value of element here. Now we put the element. What was the element? The element was 7. As 7 was smaller than 8, we put the value of 8 here and then put the value of 7 here, and now j is here. Now as we increment, now we again increment I. Now I is pointing to 3, which is 1, and j is pointing to 8. Now see, this will make you understand pretty clearly. Now 1 is smaller than 8, so we put the value of 8 here. and then we put the value of 8 here, and then and then decrement j. Now j is pointing to 7. Now 7 is also less than 1, so we put the value of 7 here and then decrement j. Now 2 is also greater than 1, so we put the value of 2 here and then decrement j. Now j becomes less than 0. Now as j becomes less than 0, we comes out of the array and add the element was 1, add the element 1 at the position greater than j. The greater than j position is 0, so we add that element here. So if you weren't able to understand it, let me show you again. Let me try to explain it again. Here we just have to check that whether the value of j is greater than or not from the value of I. As the value of j becomes greater than the value of I, we just have to put that value in place of I and then decrement j. Okay, so now let me tell you in in code. So as we did in the last video, now we are going to sum it up here. Now I'll make a class again, static void insertion sort. It will take an array. Now look at the algorithm here. Now look at the algorithm here. What it tells is that first we have to make an array which runs from I to the end of the array. Now I'll just have to run for int I is equals to 0, I is less than array dot length. I'm sorry, I just opened it. I plus plus. Okay, now we'll have to make an element that takes the value of I. Okay, now I'll have to put j is equals to I minus 1. Now I'll make a loop. I'll make while j is have to be greater than equal to 0 and array and the value at j, if it's greater than the value, the element. Okay, there is an error. See, this is our condition. The value at j must be greater than 0 and the value at if the value at j is greater than the element, then only it will enter in the array. Now what we do in the array, that we just put j plus 1 is equals to array j. Okay, as we did in here. Then we decrement j, and at the end of this array we did nothing, we just put array j plus 1 is equals to the element. As simple as that. Now let me make another loop that will show you. The m is less than array dot length m plus plus cout array m. I'll make a statement here. The sorted array is okay. So as you can see, we are taking the input here, we are entering the values in the array here. Now I'll just have to run this. Okay, let it compile. Okay, how many elements you want in an array? I want 10 elements in the array. So start entering 58, 52, 56, 0, 2, 20, 58, 89, 78, 53. How many elements we have? 8, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, sorry, I forgot to call the function in the main method. It happens sometime. In insertion sort, I'll have to just give it the input array. Okay, now it will run properly. Here 10 is the input, 56, 15, 68. Give any values you want. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Oh, sorry, there is another mistake. I'm so sorry. Okay, now this is the correct one. I want 10 element, 1, 10, 20, 56, 0, 48, 76. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is the correct array. So thank you so much for watching the video, and if you want to support the channel, well, there are a couple of ways. First, subscribe and share the video if you think that this video will help someone, and if you have any queries about this sorting algorithm, as this sorting algorithm is a bit difficult than other sorting algorithms, so you can you are free to ask in the comment section below. And if you didn't understand what's going on here, just make the array and then try to do this step again and again every time, and you'll understand, because I understand the same way. So thank you so much.